Hello, this is John Fisher from CrowdOptic. Thanks for a moment today, and thank you very much, Intel, for the invite to their IoT conference. This is important to CrowdOptic for all of the obvious reasons, including the fact that, of course, Intel is everywhere. We have built cameras from the ground up at CrowdOptic to deliver what we're calling intelligent live streaming, and Intel is in the camera in the form of an IoT compute stick. We're announcing today a partnership with Hewlett-Packard Enterprise. We have an appliance in the field with HPE over the last couple of quarters, and today we have added a drone connector to the appliance, and we're able to control and leverage the drone in a way that you haven't seen before. So that's very exciting. And of course, Intel is all over HPE architecture. We're announcing a full deployment with a key client of ours, National Bioskills Labs, and we are connecting their offices so that the likes of major medtech enterprises can do the types of live streaming that they haven't had access to before, all again under the auspices of partnerships that leverage sensor data and information to allow a different type and a very exciting type of live streaming. Both Intel and Hewlett-Packard Enterprise are all over that NBL deployment as well. What is CrowdOptic trying to say? It's a very noisy world. Why are we here? We have a proprietary algorithm. I'm going to show you a look at that. I'm going to fly a drone in front of you in a moment. An algorithm that understands where mobile devices in the IoT space are aimed in common. Everyone has the location of devices, and CrowdOptic is going to show you where these devices are aimed in common. So CrowdOptic is intelligent live streaming. We understand all of the devices on our platform from the sensor level, and that is the location of the device, a GPS, as well as the heading of the device, a compass, and a variety of other attributes. And then we have triangulation algorithms that are crunching all of those sensor attributes. We call this engagement geometry to determine where the devices on the platform are all aimed at any given moment and where they are aimed in common. And if you know this, if you have this type of context, then you can do some really exciting things. In smart cities, cities are trying to make sense of chaotic environments in real time. They're trying to get faster. They're trying to get more granular. If there is a traffic incident, for example, data shows that the 25% of all traffic in major cities are caused by incidents. So getting multiple views of the incident in real time, as I'm going to show you in a minute, launching drones or launching all kinds of IoT devices in this environment can enable new perspectives. If you know where the devices are aimed, then you can get multiple views of the same action. If you know where the devices are aimed, then you can understand multiple vantage points of the action by contextualizing a phone aiming at what a drone is aiming at, what a surveillance camera is aiming at. You can almost have superhuman capabilities, and that is you can share views from across a stadium or across a city. It's really a new form of context. We believe that we've invented a new kind of triangulation, and this is what we refer to as engagement geometry. So let me show you this stuff for a moment. We have included a drone in a new appliance that we have with Hewlett-Packard Enterprise. And I'm going to show you a video of our flying this drone just yesterday. What you'll see is the drone lifts off the ground, and you'll see another live stream of a static phone that's controlling the drone on the ground. And then we will rotate the drone in the air, and you'll see an analytics readout where the vector from the drone is rotating along with the drone. We have the drone's location, and then we have a direct line of sight of where the drone is looking as it rotates. And when it intersects with the phone on the ground, it forms this engagement geometry, meaning you, for the first time, can aim a phone and you can get the perspective of where the drone is looking. Now, a better way to understand this is imagine 10 drones in the air. You can aim your phone and then seamlessly pick up the applicable view of whatever drone is also aimed in the direction that you're aiming, again, through this triangulation algorithm. Take a look at what this looks like just for a moment. Now we need a link to this. So that is a new way to control and to leverage a drone. What you just saw was the phone on the ground providing the line of sight in order to rotate the drone in a various direction. The drone completed a circumference, and you saw the lines of sight at the top of the screen, the analytics readout. So what this is a platform that is harnessing both the location and the direction of all the devices on the platform, and the understanding of then when these devices are intersecting. And just once again, to understand what that use case means, we think is illustrated in the recent Hewlett-Packard Enterprise CrowdOptic appliance, which you can see on your screen. It comes in a few different pieces. That's all available in a turnkey kit that we're shipping. First, it's the HPE Edgeline server. This can be in any location. It can be an enterprise, but very interesting. It can also be in, for example, moving vehicles. You put the server in the trunk of a car. You see a little image of some of the live streaming cameras that we've built on the right of the logo there. So we line this connected car with a bunch of our cameras with all of the applicable sensor data that's required to broadcast these vectors. And then as this car convenes on a scene, let's say it's a police officer or fire, as it races through a connected city with a host of other devices that are being worn or surveillance cameras that abound, all of a sudden you can tie in the perspective of this car to its environment, to the connected city through this type of context. And the logo in the middle, you see the HPE infrastructure, you see the CrowdOptic Eye, that's our handmade camera. The logo in the middle shows these various people aiming at a point in space using various objects. And we are, which is the secret sauce of CrowdOptic, we are able to contextualize this point in space. And this is a look at what we mean by this engagement geometry. The thesis behind this company and what's allowed us to be in production for the last couple of years in IoT is to deliver what we're calling intelligent live streaming, and that is understanding at a sensor level the various devices that are in the real world and providing a higher quality, a more granular live stream because of this. We're able to detect areas of interest, objects of interest. We can find those and develop experiences. We can query the videos and images or whatever content is produced by these devices. So God forbid, we're reading about these tragedies that are happening in this country and around the world. And very quickly, smart cities, law enforcement, these entities know where something has happened, but they're trying to get more information about it. So with these type of algorithms and with Intel's help. I'm pleased to report that we are in a pilot engagement with Intel as well, with the Hewlett-Packard Enterprise Partnership. We're finally getting these algorithms into a platform so that they can be used to enable enterprises to see and act more quickly based on what's going on in the real world. You can query by location, by information. Everyone has that. You understand where devices are located, but you can also query by line of sight. You can also query by the object of interest. This gives you a quick look at the specs of the drone partnership that we're just rolling out today. And you saw the video. You have the ground controller. You have the HPE server infrastructure. You have the smaller servers that go in the moving objects like cars or buses or trains or trucks or thereabouts. And then you have the larger servers that are used on-premise, command and control, and thereabouts. This is used once the information is already stored for increased storage and also querying. Interesting thing that we're discovering also in IoT, and Intel, of course, is playing a key role, is the ability to have a hybrid processing of information. So we'll show thumbnails in the moving vehicle or in command and control that originate from the cloud, and we'll do some minor processing at this level. But then for the harder core stuff, for the high definition video and some of the advanced processing, we'll do at the server level. Now, to process our algorithms as far as the triangulation and thereabouts, that also occurs in the cloud. But the point is a consolidated live streaming interface. Instead of doing, for example, LTE from all these different devices that you'll find in the connected car, you can now do it from one server. As far as the thesis of only being able to work in the cloud, or for that matter, on the server, now you can work with both methodologies. And so it serves to be a key value proposition for our clients to have the option to store both ways and to use the information in both ways. Of course, I mentioned that Intel is all over this solution. It's the GL20 HPE server that we're typically using. That is a smaller and lighter weight server, but of course very ruggedized and able to withstand the you'll find in traveling at 60 miles an hour. And of course, the Intel solution is and processors are in that. The Intel stick is in our CrowdOptic Eye. This is a handmade device that can take a variety of different forms. We're mounting this on helmets. We're putting this on lapels. We're lining hospital rooms and connected offices with these devices. I mentioned a key partnership that we're announcing today with National Bioskills Laboratories. That may not be a name that you've heard of, but they're, we believe, the first major outfit in the country to connect their offices in this way, using these type of cameras and this type of technology, so that, again, some of the largest med tech companies in the world have an outsourced ability to process their live training and other information. And the way that NBL has connected its offices using both HPE, Intel, and CrowdOptic infrastructure is a first. Specifically, live views of training. I've showed you technology with a drone that's applicable to multiple views. In surgeries, you want the same multiple views of a procedure. You want 99% uptime, which an understanding of the sensor quality and information is necessary in the live streaming. So we're in a variety of different verticals, both the government, the SLED, the state, the local, and education vertical. We're in medical. We're in sports and entertainment. An understanding of devices this way is critical when, for example, you're deploying for the Broncos during their all-important AFC championship game. They can't have technology go down in those situations. So we've been in these various verticals for a couple of years in production. And then, as I mentioned, we're just starting to partner with these great companies to bring the platform forward. Another thing to appreciate as far as where we see IoT going and what's really happening in this space. We think live streaming, we think broadcasting video is a market that we all understand, but we also think that this type of technology can serve to bridge traditionally siloed technologies in smart cities. These smart cities have dozens of vertical applications that are just now starting to better communicate and talk with each other. But again, if something happens in a traffic situation and something happens with an anomaly or an incident response, if God forbid there are gunshots originating from an area and you need to get more perspective, well, we can locate gunshots. That technology is around. By we, I mean the industry. You can do that via radar. But then what? Then how do you really hone in on what's happening? And imagine interfaces that you'll see where once you have the location of the action, and don't get the wrong idea about location. This isn't every man's location. This could be a location on the top of a rooftop, or what we just saw in Las Vegas out of a window. Location is in 3 dimensions. Once you understand where the incident is, then this is the type of technology that can pull all connected devices into that location, again, by the location, by the devices that actually have the incident in their sights. Or you can just let the algorithm run wild on all these devices and it will catch significance. If you have 100,000 devices at one of the world's largest events, chances are something of high significance will be made known if only 10 or 15 or 20 of these devices are looking at the same thing at the same time. We're pleased to have a key patented advantage. The engineering team and I have worked together on multiple ventures over the last 20 years. It's been a good run for all of us. This particular basket of patents that were issued have really been exciting, again, because we think this is a new form of triangulation, a new form of understanding the world in this way. Just imagine, hold CrowdOptic and my evangelizing for a moment, but just imagine a world with all of these devices in these smart cities, in these connected environments, the IoT world that we're starting to understand. And just imagine how many intersections in this way these devices have per second. Every time you see something significant in the world, chances are you see people aiming their phones at that significance. And that significance is this engagement geometry. The people, either through our platform or serendipitously or anything in between, are honing in on what and where the significance is. Think about how devices operate in the real world. Once we get more intelligence in our glasses, now that we're aiming our phones around not just to take pictures, but to do real things in the environment. Of course, drones are becoming more and more ubiquitous. And a drone, just like a phone or a camera for our purposes, is just the same collection of sensors that we can leverage in this way. So this notion of engagement geometry, where you're analyzing the device sensors for the awareness of a group, of a crowd of devices, a crowd of people, to get more granular views of incidents, more understanding in real time of what's happening by layering new metadata of this kind into video and into imagery files. It's very exciting to see the market keep up, not only in terms of connectivity, not only in terms of sensor quality, but also in terms of just the raw nature of how data is stored. The sensor information that we need has long been a standard in EXIF data in images. We're now seeing improvements in video, and even the browsers themselves. We're seeing the WebRTC format work a lot better for the delivering of the live streaming that we're working within. We're seeing web pages overall host more and more of the raw data necessary to provide not just the location data, but vector data. And if all this seems a bit Orwellian, a bit spooky to really understand where you're looking through your devices, where machines are looking, we appreciate that. But in the end, we think the offset is that this stuff, across the board can save lives. I repeat, when you have one of these incidents happen, one of these terrible incidents, one of these confusing incidents happen in the world, it takes the organizations that we trust, from the enterprise I've already mentioned, like Intel and Hewlett Packard Enterprise, to CNN, to to folks in between, it takes them a little while to figure out truly what's happening, and especially to get a visual on it. And if this is a type of technology using partnerships with the likes of Intel and HPE that can give the world a more granular and a faster look at incidents, then you get faster incident response. Of course, the smart cities start to deploy faster and faster. They save money, but they also save lives. And the studies that show that 25% of traffic is due to incidents is one thing, but the studies that show that a 2 or 3 minute decrease in response time can save 25,000 lives over the course of a unit of time, over the course of a year. That's really stuff that gets the engineering team and I up in the morning. So I wanted to thank you for listening for a moment. I'll tune out of the presentation and perhaps take any questions if there are out there. And thank you for the invite again, Intel, and for the great partnership, and as well as Hewlett Packard Enterprise.